Hi, Assalamualaikum and good day. Today we are going to learn the operation on matrices. This is the objective of our lesson. By the end of this session, you should be able to do operation on matrices. There are 6 operations on matrices that you need to learn. Number 1 is on equality of matrices. 2. Scalar multiplication on a matrix. 3. Addition or subtraction on matrices. 4. Multiplication between matrices. 5. Transpose of a matrix. And 6. Power of a matrix. Performing the addition, subtraction, and scalar multiplication on matrices are exactly the same as performing this operation on numbers and algebra. However, matrices are multiplied differently as compared to number and algebra, and a matrix cannot be divided by another matrix in the same manner. Let's start with equality of matrices. Two matrices A and B are said to be equal if and only if they have the same order and Aij is equal to Bij for each I in J. For example, given two matrices with the same order or size, for example 2 by 2 matrices, if these two matrices are equal, that means the corresponding element inside both matrices should be the same. A equal to W, B equal to X, C equal to Y, and D equal to Z. Take note that the two matrices are not equal if they got different size. Let's refer to the first example. Suppose that the following two matrices are equal. You need to find the values of X, Y, W, and Z. By equating the corresponding element, you should get X equal to 2, Y plus 1 equal to 7, therefore Y is 6, 2Z equal to 4, therefore Z equal to 2, 5W equal to 2, therefore W equal to 2 over 5. The next operation is on scalar multiplication. Consider A be any matrix and lambda be any number or function. Then lambda A is defined to be the matrix obtained by multiplying every element of A by lambda. Now let's do example 2. Given matrix A, you need to find 2A and negative A. In order to find the answer for 2A, you need to multiply all the elements in matrix A with 2. Therefore, you should get 2, 0, negative 8, negative 4, negative 2, and 6 as the answer. As for negative A, you need to multiply all the elements in matrix A with negative, and you should get negative 1, 0, 4, 2, 1, negative 3. Next operation is on matrix addition and subtraction. For this operation, the two matrices must have the same order or size. Otherwise, addition and subtraction cannot be performed. Consider two matrices with the same size, A and B. A plus minus B is obtained by adding or subtracting the corresponding element of A and B. Refer to example 3. Given the two matrices A and B, find A plus B and A minus B. As the two matrices A and B having the same size, which are 2 by 3, A plus B and A minus B are defined as follows. A plus B is obtained by adding the corresponding element in both A and B, as A minus B is obtained by subtracting the corresponding element in A and B. Let's proceed with the next operation, that is on matrix multiplication. Consider two matrices A and B. A has m rows and r columns, and B has r rows and n columns. Then the product of AB is defined to be matrix C and given as follows. The size of the product AB is m by n. The element Cij is obtained by multiplying the element of the ith row of A with the corresponding elements of the jth column of B and summing the result. For matrix multiplication, the number of columns in the first matrix must equal to the number of rows in the second matrix. Otherwise, the multiplication cannot be performed and the product is undefined. The size of the product is determined by the number of rows in the first matrix and the number of columns in the second matrix. For example, when matrix A with the size of 2 by 2 is multiplied with matrix B with the size of 2 by 3, the size of product AB is given by 2 by 3. 2 by 3 here means the product consists of 2 rows and 3 columns with 6 elements inside. In order to calculate the answer for each element, refer to the double subscript which indicate the row and column need to be multiplied. For example, C11 is determined by multiplying the first row of the first matrix and the first column of the second matrix. As for C21, it is determined by multiplying the second row of the first matrix and the first row of the second matrix. Refer to the following example. The first matrix consists of A11 and A12 in the first row, and the second matrix consists of B11 and B21 in the first column. By multiplying the first row and the first column here, you will get A11 times B11 plus A12 times B21. So this will be the answer for C11. Refer to example 4. Given two matrices A and B, you need to find AB and BA. First thing you need to do is to check the size of the product AB. As A is 2 by 2 and B also 2 by 2, the size of AB should be 2 by 2 as well. Meaning, there are 4 elements that you need to determine, which are A11, A12, A21, and A22. A11 is obtained by multiplying the first row of the first matrix with the first column of the second matrix. You will get 3 times 2 plus -1 times -1, which is equal to 7. Next, A12 is obtained by multiplying the first row of the first matrix with the second column of the second matrix, and you will get 3 times 0 plus -1 times 2, which is equal to -2. Do the same process for the rest. You will get A21 is -2 and A22 is 4. For the product BA, the size of this matrix is also 2 by 2, meaning you should obtain 4 elements inside, which are A11, A12, A21, and A22. By doing the same process as what you did for AB, you will get the answer for BA is 6, -2, -3, and 5. Let's proceed with the next operation, that is on transpose of a matrix. Consider a matrix A with the size of m by n. The transpose of this matrix, denoted by A with the superscript T, is obtained by interchanging its rows with its columns. the size of transpose is reverse of the original matrix, which is n by m. Refer to example 5. Given two matrices A and B, you need to find the transpose of this matrix. The size of matrix A is 2 by 3 and B also the same. Therefore, the size of transpose for both matrices should be 3 by 2. By interchanging rows with columns, you should get the following answers for A transpose and B transpose. The last operation is on power of a matrix. Consider matrix A. A to the power of 0 is equal to identity matrix. A to the power of 1 is equal to the original matrix. A to the power of 2 is equal to the matrix multiplied with itself 2 times. A to the power of n is equal to the matrix multiplied with itself n times. The law of exponent is valid for powers of a matrix such as A to the power of P multiplied with A to the power of Q. The answer is A to the power of P plus Q. And A to the power of P to the power of Q is equal to A to the power of PQ. Refer to example 6. Given a matrix A with the size of 2 by 2, you need to find A to the power of 2 and A to the power of 3, then MA, in which MA is equal to 2A squared minus 4A plus 5I, where I here is referred to the identity matrix. A squared means A multiplied with A. As A is a 2 by 2 matrix, A squared should have the same size, which is 2 by 2, meaning you need to obtain 4 elements, which are A11, A12, A21, and A22. By multiplying the elements in the corresponding rows and column, you should get the answer A11 is 9, A12 is -4, A21 is -8, and A22 is 17. As for A to the power of 3, you need to multiply the answer for A squared with matrix A. As both matrices having the same size, which are 2 by 2, A to the power of 3 should have the same size, which is 2 by 2 as well, meaning you need to find or obtain 4 elements here, which are A11, A12, A21, and A22. By multiplying the corresponding rows and column, you should get the following answer. Next, to obtain the answer for MA, you need to apply the following operation. 2A squared minus 4A plus 5I, where I here is referred to the identity matrix. As for addition or subtraction must involve the same size of matrices, the identity matrix here should have size of 2 by 2, which is 1, 0, 0, 1. By doing this operation, you should get the following answer. Following is the exercise 1.3, which you can try on your own to get better understanding on today's lesson. In the next lesson, you are going to learn about determinants.